Okay, so here's a sample problem, and this sample problem should help you solve some of the homework problems. And the problem simply reads the derivative at x equals -3 and x equals 2. We're given this ellipse. It's actually a semi-ellipse because it doesn't include the bottom half down here, but it's close enough. And the semi-ellipse has the advantage that it's a function. You can't take the derivative unless you start with an actual function. Anyway, so since we're given 2 points on the x-axis, x equals -3 and x equals +2, then the derivative is going, the answer is going to be 2 actual numbers rather than functions or something like that. And that's because we're not asked to find the derivative of the entire function, we're just asked to find the derivative at these 2 particular points. So first let's figure out where these points are. X equals -3. First of all, notice that each increment on the axis is 1. So each box is 1, which is not necessarily going to be the case for the other problems that you are going to solve. But x equals -3, that shows up right here. Follow it up until it hits the axis, and you've got a point right there. Okay, and then we'll draw a tangent through that point. It looks to me like that tangent goes right about there. Now, given that drawing these tangents is kind of a human endeavor, there's going to be a little bit of error involved in each of these tangent drawings, and so I'll tolerate some degree of variance from one individual to the next. But you should get something kind of like that. All right, we also need x equals. So here on the x-axis, we go to 2, and then we go up till we hit the graph. And then we position our ruler so that we get a nice tangent line that captures the local rate of change. And I'm actually going to, how about I change colors for this one? I'll do this one in, let's try this kind of tennis ball green here. And it helps to draw your tangents really long. That way, if you're off by a little bit over a long span, it's not that big of a deal. Okay, so we got our tangent lines, but that's not it. We have to actually find the derivative, and the derivative is the slope of the tangent line. So in order to get slopes, we need to find 2 points on each line. Okay, so this point here is both on the tangent line and it's on the graph, so we can use that. It's at the coordinate 2, x coordinate -3, y coordinate 2. So that's going to be that. And then we'll find another point. Unfortunately, the red line doesn't hit the grid really nicely. But let's see where it gets reasonably close to something we can estimate. Well, we might as well pick at least one grid line. And like I said, try to keep these things kind of far apart so that you have a nice big span. Okay, so this is going to be x coordinate of -5. This is going to be our second point. And remember, your points only have to be on the tangent. They don't have to be on the graph. So this is x is -5, and let's see, that's the halfway point, so that would be the 1/4 point. I'll call this 1/8, which is, I believe, 0.16. No, 1/8 is, let's work that out real quickly. That's about 0.12. 0.125. So we apply the same rules for measurement on a graph that we do on any other measuring device. So technically these are 3.0 and 3.0. Our smallest increment is 1. We can estimate to 1/10 of the smallest increment. So that means that we get a value of 0.1 over here. Okay, so if for the red line, we do our slope calculation. So that means that d y dx. We'll just call these the x and the y axes. Forget about all the other complications I involved. But we got get our change in y, so that's going to be 2.0 minus 0.1 divided by our change in x, so that's negative 3.0 minus negative 5.0. Okay. Don't forget, you're subtracting, but it's negative. Okay, so the denominator, actually let's work downwards. The denominator comes out to positive 2.0. The numerator comes out to 1.9. And so this, give me a calculator 1 second. Where'd my calculator go? Here we are. All right. So this calculation is going to come out to 1.9 divided by 2.0, and that's going to be really close to 1, or it's going to be 0.95. And since we had two sig figs in the numerator and the denominator, our derivative at this point is 0.95. Okay, over here, we can select this point, and this is going to be the point x is positive 1.0, and this looks like it's smack dab on the y=3 line. And over here, again, it helps to have, for accuracy's sake, it helps to have your 2 points kind of far apart. Might want to use that one because that looks like about negative 1.5. But anyway, this is a coordinate, has an x coordinate of positive 5.0 and a y coordinate of, let's call it 0.3. It looks about 0.2, somewhere between a quarter and a third, and besides, we can only get one digit after the decimal point anyway. So for the green line, we're going to say that dy dx is going to be the change in y, so that's 3.0 minus 0.3, divided by the change in x. Sorry, did I in the previous one say change in x? In the top goes your change in y, on the bottom goes your change in x, and remember the tangent, not for the graph itself. Okay, so with the 3 along goes the 1, and with the 0.3 along with that goes the 5.0, and so this comes out to 2.7 divided by negative 4.0, and that's going to be a negative slope, and that makes sense because we got a downward, sort of downhill angle here. At 2.7 divided by negative 4.0, you could leave the 0.0 off of your calculator, but this comes out to, with two sig figs, negative 0.68. So that's our best estimate for the slopes at these 2 points. And the slopes, as I've said before, are the same thing as the derivative.